All right, let's dive right into this. In this explainer, we're going to unpack and really demystify a document that is absolutely crucial for modern cybersecurity. I'm talking about the NIST catalog for federal IoT security. Now, we live in a world where literally everything, from the thermostat on your wall to massive industrial sensors, is hooked up to the internet. Securing all those devices? Yeah, it's one of the most complex challenges we face today. So this specific publication, NIST Special Publication 800-213A, is basically the ultimate playbook for making sure these devices don't become the weakest link in a network's armor. So here's our roadmap for today. First, we'll look at the IoT security challenge. Then, we'll introduce the NIST catalog itself. After that, we'll break down built-in versus supported security. And finally, we'll take a look inside an actual security requirement.
All right, Part 1, the IoT Security Challenge.
Before we start looking at solutions, we've got to understand why internet-connected smart devices need a totally different security mindset compared to, say, your standard laptop. So, according to NIST, an IoT device has to have at least one transducer. Now, that's just a fancy word for a sensor or an actuator, something that interacts directly with the physical world. Plus, it needs a network interface, like Wi-Fi or Bluetooth, to talk to the digital world. Essentially, it has the fundamental hardware to act completely on its own.
And wow, you really have to think about the immense stakes of that definition for a second. These devices aren't just sitting in some air-conditioned data center crunching numbers. No, they form a literal bridge between real-world physical actions and our digital networks. Think about it. A compromised laptop might leak some sensitive data, sure. But a compromised IoT device? It could manipulate the actual physical environment. We're talking about changing a temperature gauge in a lab, unlocking a secure door, or shutting down a critical water valve. That intersection of physical and digital creates incredibly unique and honestly, sometimes dangerous vulnerabilities.
Moving on to Part 2. Enter the NIST catalog.
So to defend this massive physical-digital bridge, the federal government realized they needed a standardized shield. And enter NIST Special Publication 800-213A, the IoT Device Cybersecurity Requirement Catalog. Now, to be clear, this isn't just a casual list of good ideas. It is the federal government's comprehensive playbook to guarantee that any IoT device plugged into a federal system actually meets a really rigorous set of security standards.
The core purpose of this document is captured perfectly right here. This publication is intended to help federal organizations determine device cybersecurity requirements for IoT devices they seek to use with federal information systems. But, it doesn't work in isolation. The document specifically notes that it has to be used alongside the primary guidance found in SP 800-213, as well as the broader NIST Risk Management Framework, or RMF as it's usually called. When you put them all together, they allow an organization to properly assess the risk of a brand new device and just vastly boost their overall security posture.
Which brings us to Part 3, built-in versus supported security.
Now, this catalog itself is massive. Seriously, it's a lot to take in. So NIST very smartly slices all these requirements into two fundamental categories. On one side of the coin, we have device cybersecurity capabilities. These are the technical features, the actual hardware and software built directly into the device itself, like, say, encryption. On the flip side, we have non-technical supporting capabilities. And these are external actions performed by the manufacturer, like sending out vulnerability alerts or providing training on how to run updates.
Let's dig into that built-in technical side first. The catalog basically outlines 7 broad capability categories. You've got your foundational features, right? That's device identification and device configuration. Then you move into active defenses, like data protection using secure storage and logical access to manage exactly who is allowed to connect. To round the whole thing out, the device needs software update capabilities, cybersecurity state awareness, which is just a fancy way of saying it needs to monitor its own health, and overarching device security to ensure safe execution. I mean, it's a remarkably broad spectrum of technical defense that these things have to have.
But here's the thing. Just having a technically secure device isn't enough anymore. It absolutely requires active, ongoing support. So, manufacturers have to provide 4 non-technical supporting capabilities. First off, detailed documentation about maintenance and how the device works. Second, information and query reception. Basically, they need a dedicated pipeline to receive vulnerability reports from users. Third is information dissemination, which means pushing out active alerts when something goes wrong. And finally, education and awareness. This gives users super clear expectations on things like data backups and, how to safely dispose of the device once it reaches the end of its life.
All right, on to our final section, Part 4, Inside a Security Requirement.
To truly appreciate the genius of how this catalog is put together, we've got to look at the anatomy of a single standard. This breakdown, straight from the NIST publication, shows us exactly how an organization starts with a really broad capability at the top level and then systematically drills down into highly specific sub-capabilities, complete with identifiers, definitions, and control mappings. It is just an incredibly organized way to tackle what is otherwise a very messy, complex subject.
It's kind of like a Russian nesting doll. Federal administrators don't just get handed this massive, overwhelming list of technical jargon. Instead, in Step 1, they identify the broad capability they need. Step 2, they drill down to a specific sub-capability. Step 3, they see exactly how that sub-capability maps to existing SP 853 Revision 5 security controls. And then finally, Step 4, they get specific, actionable requirement statements. It totally prevents overwhelming the user while still giving them those exact, rigorous technical mappings.
Let's actually look at a concrete example straight from the text to see how this works. Say a federal organization decides their IoT devices absolutely must help them detect incidents and troubleshoot problems. Well, they'd start by looking at the broad capability called CSA, Cybersecurity State Awareness. Drilling down one level, they'd find the sub-capability labeled AEI, Access to Event Information. And this is basically the specific ability to access the IoT device's operational state information whenever necessary.
So the crucial point here is how this actually translates into action. For this specific sub-capability, the requirements dictate that the device must allow access to its cybersecurity state, and it has to preserve system state information. But crucially, this maps perfectly to established federal controls, specifically SI4, AU11, and AU12. And that is the magic of this document. It ensures that the individual IoT device, no matter how tiny or seemingly insignificant, fits perfectly into the massive existing puzzle of federal information security.
Which leaves us with a really fascinating thought to wrap up this explainer. We've just navigated this highly complex playbook that was designed to protect government networks at the absolute highest level. But the IoT market is highly interconnected. If these intense NIST requirements, everything from strict device identification to mandatory vulnerability reporting, become the new baseline for federal systems, well, how long until they shape the standard for the smart devices sitting in your own home? As manufacturers adapt their products so they can sell to the government, those exact same physical digital security bridges might just end up protecting your living room. Thanks so much for learning with us today, and keep exploring.